All right, I'll be fast. So we've been pushing pixel local storage for like 3 years now. We took a break. It's almost done. 100% implemented the spec and tested in Angle, implemented in Chrome, coming to Safari. It'll be here soon. On top of pixel local storage, we are now doing Gaussian blurs. And slides are boring, so let's go to the demo. Okay, so here's a shape. And in vector graphics, a common technique is to blur your shape like that. And the way people do it typically is you rasterize your shape into pixels, and then you do an extremely expensive convolution filter on those pixels to get a blurred edge. And what's funny about this is that Gaussian blur is actually like an image vision. It's used in computer vision to find edges. So we try to make, and Bezier curves to begin with already are edges. We have these Bezier curves in vector graphics. They're defined mathematically as beautifully defined edges. But instead of just blurring those edges, we rasterize them, throw away the edges, do an expensive convolution filter, and it's really slow. And people get drop shadows and a few of them, and it gets clunky. So at Rive, we take a different approach to this. If we think about the area that is affected by the blur, it's just here. Like if I want to blur this image, this is all filled, this is not filled, just the area in here is what's blurry. And so instead of doing a convolution filter, rasterizing it, we just draw this border and we do some fun compute shaders, and we get a blur that is drawn, nothing off screen, no convolution filter. It's just, we call draw elements instanced index, draws those triangles, and we get a blurry thing on the screen. So to look a little bit about how this works, I'm going to look at a box, turn off the join. 1 second. Okay, so here are the edges of our blur. And if I just look at these edges, there's an inside and an outside. The inside is red. Red means negative. Outside is white. White means positive. And here's the inside rectangle that is not anti-aliased. If using pixel local storage, I draw these edges on top of this square, this red negative coverage subtracts from the rectangle, and it looks almost right, except for the corners. Along this edge, by the way, we're doing a just one-dimensional SDF, evaluate the integral of the Gaussian function, and it gets a nice feathered fall off. To finish it off, we do these little interesting join things. This is where it gets hard. These are no longer simple SDFs. Inside of this little circular join thing, I will actually turn that off. Okay, so without those, corners look bad. So we draw these corners on top again with pixel local storage. So these come through add to, subtract from coverage. And we get a shape that looks like a Gaussian blur. Along these corner things, what we do is in the shader, we evaluate this cute little integral right here. And then it works. And I derive this integral. I don't actually really understand how any of this works, but these corners, so backing up, I'll turn on these corners. Yeah, okay. So here it's kind of negative, here it's kind of positive, and that's great because we kind of need a little more here and a little more here and a little less there and a little less there. So I don't know, do this integral, gets a little less positive, more negative, adds together, and whatever, it works. Looks like a Gaussian blur. And so now I'm going to switch. I'm going to show a real Gaussian blur. You can see in my title. Here's a Gaussian blur. Watch really closely in case you miss it. Here is Rive's vector feathering, and they look identical with the exception that, again, this feathering is not going off screen. It's not doing a convolution filter. It's literally making one draw call, these triangles to the screen using WebGL pixel local storage. And we have a blurry thing. So this one's easy, has just straight edges. I'm going to switch to a aesthetic shape that I designed myself. And this one's hard because it has curves. And if you imagine how a curve goes through a convolution filter, it's not easy. It curves through the thing, and the convolution filter is a two-dimensional integral of the Gaussian distribution, and then there's a curve going through it, so it's hard. So what we do is chop up curves by constant changes in rotation angle. So every n degrees, we chop this up and add one of these cool joiny things. Those do this weird integral that does something. And we flatten each section just a little bit, because when you curve through a Gaussian filter, you get softer. So we flatten it, do a bunch of math, and there you have it, a blurry thing. Again, I'm going to do Gaussian blur and vector feathering. If you blink, you'll miss it. We can get as blurry as we want, and it just works. Cool. I will go on to some demos real quick. So here, why are you here? Okay, here's an example of a game demo built using Rive now with feathering for fun. Down here we have feathering, these rune things. If I hover over the menu, all these lighting effects are using this vector feathering. I can click here and those are lit up, feathering everywhere. It's using, again, the thing we went over. I will show you what this looks like if we use 2D HTML canvas and its filter function, which is a Gaussian blur. So I will turn on canvas. Okay, here is a, oh, well, maybe not. Cool. Here it is on canvas using a Gaussian blur, stepping constant amounts of time each frame, so you can kind of feel the frame rate. The thing comes, it's slow, slow, slow. Then if we switch back to using vector feathering, what's going on? Yeah. Anyway, I'm screen sharing. I'm not sure what's going on anymore. Anyway, it looks cool. I'm going to do one more demo that's full of feathering. Cool. Yeah, here's another one. An artist at Rive built. Super cool. All of the, okay, low resolution, so these buttons are too big. That's unfortunate. But all these little hair things are feathering all over the whole thing. 2D vector, very small file, and all built using the vector feathering. If I come into the Rive editor, I'll just show you a few more. Somebody built this controller, which is vector art. Yeah, PlayStation controller. Yeah. Hooked up to a joystick. You can kind of move the shadows a little bit. Let's do one more. Oh yeah, this coin's pretty cool. Again, I'll just we call it feathered vectors, Gaussian blurs, except using pixel local storage and the blurry stuff we just looked at. Oh yeah, these weather icons, these are fun. That sun is kind of spinning behind the cloud, and the artist has set this up so that these vectors are all feathered and it kind of looks like it's behind a glassy thing. Anyway, that's all. By the way, we're hiring, so reach out if you want to come work on this stuff. Any questions before You move. Thanks.
So you say it's shipping soon? How soon is soon?
The Pixel local storage extension.
Yes.
I mean, I want it to ship right now. We are waiting for. It's just being put into WebKit right now so that it can be shipped with Safari and Chrome at the same time. And Ken might have a better answer to how soon.
No pressure. I don't have a microphone.
I think that's a good idea. Yeah. Yeah. I don't know, maybe.
It has to get approved by all the browsers. So. The extension has to get approved by all the browsers. Not quite there yet. We got to get, the last agreement on the shape of the API, whether it be, to the getting rid of the allow list or put it back in and lock out some of the WebGL APIs when you're PLS. Figure that out in the next few weeks.
Thanks. Yeah.
You mentioned that it uses SPS and the operate part of the transition. Why do we not use SPS for everything and just use the data textual from to
Yeah, I can answer that. So in the very easy case, which is a flat edge, you can effectively do an SDF of the edge and then run your distance through a Gaussian function to get this fall off. On corners, you can't do it anymore because over here, if you imagine your convolution filter, it gets affected by that edge and by that edge. So you just can't do an SDF anymore. And then if it gets even more complicated, like you make it bigger, all of a sudden this pixel gets affected by that edge, that corner, that edge, that corner, all of these things. So you just can't do an SDF for anything but the very simple case of a flat edge.
I see the page, but I will
Okay.
before I continue.